Well, we'll go ahead and get started. This is Michael McClellan. I'm with Levine Electronics and Lectronics. Thank you all so much for coming to another webinar. I think you'll find this one very, very interesting. We're going to cover some of the changes in the market to equipment offerings for modular UPS, uninterruptible power supplies, and some of the caveats to watch out for when the word modular is used, because there's a sort of an interesting trend in the market, and sometimes modular does not necessarily mean online swappable. So Jürgen's going to tell you more about that. Your phones are muted. You're in webcast format, so we want to eliminate all the background noise so that you can all hear Jürgen's beautiful accent. We'd love for you to interact with us, though, and ask questions. There is a question box. I believe it's in the lower right, maybe lower left-hand corner of your screen. And we'd love for you to ask any questions, and if appropriate, we'll stop and answer them, or we may save them till the end of the session. So again, thank you so much for attending. I'm going to turn it over now to Jürgen Madsen, who is Business Development Director at ABB Critical Power.
Okay, thank you, Michael. And yeah, my name is Jürgen Madsen. I am with ABB. And then as I understood from right now, you probably is not able to respond. But the question box should work, and I actually managed to get that up on my screen here. So if you can't hear me, please just put a note out there, because I'm right now using the laptop, the speakers and the microphone there, but I have the option to dial in on the phone also if there should be an audio issue. So, but getting started, and like Michael said, the majority of this will be modular UPSs and how this is developed, and some of the pros and cons in when it comes to modular UPSs. I'll take a couple of steps back and actually start out. So there'll be a little bit of history. There'll be some how has this developed, and why are we where we are today, and what led to this UPS wise. So there will be a little bit of like general history. There'll be an UPS across the board, but the main focus will be modular UPS. So before I go in, and I presented a couple of times on the Levine Electronic and Electric seminar. The opening slides may be familiar to at least to some of you. And before getting started, just my name is Jürgen Madsen. I'm with ABB. Michael mentioned the accent, and as you can tell, I was not born in the US. I've been here for well over 20 years now. So I guess I just don't have an ear for language. But as long as I can understand you perfectly, as long as you can understand me, that it usually works. I've been in the UPS business all my life, starting out in Europe, and then over 20 years in the US market, with a few different of the leading vendors in this industry. Like just looking at like like 5-10 years back, I actually had a 5-year stint with GE prior to joining ABB, and I joined ABB 5-6 years ago. That's a little interesting, if nothing else, to me, because ABB acquired GE Industrial Solutions was just over 2 years ago, was finalized. So my good old colleagues from back then are now my new colleagues, and the product offering from like the ABB product offering across the board, but obviously on the mission critical world also, is what we refer to as best of both. We've spent a couple of years in refining, completing new development, refining some, and picking the best product for a complete portfolio. Mentioning that because I do know that I have some product pictures, and of course that would be ABB products in this presentation, and some of them I noticed this morning actually still have GE logos on them. That's my bad. They will all be ABB, but some of the product are what we refer to as legacy GE, came in with the GE acquisition. So getting into the presentation. Okay, here we go. Sorry about that. Seems the laptop is a little tired this morning. So, like I mentioned, just excuse me, just an introduction into there are a couple of slides. I'll go through this quick, but the first one is just what is a UPS, like just background, where and why is it needed. And the UPS is essentially a filter. UPS is uninterruptible power supply, and it filters out whatever's coming from the utility. Most of the time, clean power, exactly what's needed for any load, including critical loads. Sometimes it's not completely clean, and the UPS takes care of that. It cleans it out and creates a clean sine wave for the critical load. The uninterrupted part comes in that there's an energy storage, a battery connected to the UPS, so the UPS can take power from the utility or it can take power from the battery. So the main components in a UPS is, like we see at the bottom of the slide, single line of a what we know as a double conversion online UPS system, where the mode of operation is that the power is coming in from the left from the utility to the rectifier. The rectifier is rectifying that from the AC to a DC and feeding that DC to the inverter. The inverter chops it off again and creates a clean 208 volt or 480 volt sine wave and feeds that to the critical load. What makes it uninterrupted is that the battery that's connected, connecting DC power to that same DC bus, the inverter doesn't care whether it's getting DC power from the rectifier or from the battery. As long as there's power on one of them, it's good to go. So that's the uninterrupted part. If power from the utility fails, the inverter will continue on the battery. And if power stays out from the utility, hopefully there's a generator that can kick in and start feeding the rectifier. Other than that, it'll be over when the battery runs out. The other the level above the rectifier inverter is the third power model in a UPS static bypass switch. That's a save the day device. If something happens downstream where the inverter cannot feed that load, can be an overload or a short circuit, or could also be a fault in the inverter. So that regardless, the UPS control will detect that there's a load situation that the inverter cannot handle, and it'll fire the static switch, it'll transfer the load directly to utility power. So if it's an overload, it'll clear, hopefully trip the breaker or blow a fuse, and the UPS will go back an inverter. That's the basic functionality of the UPS. One extra comment on this is that UPS manufacturers have found out, as customers have really been pushing for higher efficiency, is that if you leave the UPS on the static bypass, it's got very high efficiency, like just up over 99%. And which is in the business, it's referred to as economy mode. The UPS is in bypass. So it doesn't offer the filter function that a UPS normally will. But it's still, even in that mode, the inverter is just at that point asleep, but if power from utility should fail, it can still kick in and start feeding power from the battery to the load. It's not a new function. It's been around in the UPS business for a couple of decades. Hardly any customers use it because it's not a full UPS function. So much about that, and then moving on just quickly through the next couple of slides. I mentioned the double conversion UPS as we know it have been around. It's coming up on the 60 years birthday. The picture on the left part of the slide here actually is like relative to my background, but also the current. That's actually a GE UPS from the early 60s. SCR based on GE thyristor or SCRs. And then the product on the right side is a modern one megawatt UPS. The 1 megawatt is probably more compact than the 185 from 60 years ago. The single line is very similar though. Main difference is that back then we needed very heavy filters and transformers, a lot of magnetics to make this work, to protect the semiconductors against too high voltages and to filter out a lot of harmonics. Modern UPSs are based on transistors, actually IGBTs, very fast switching. And I'll go to the next slide. At the bottom right, just shows how better and better components from SCRs to bipolar transistors to IGBTs can now be switched so that the switching pattern is very close to a sine wave. This is true. This is not only on the inverter side, but on the rectifier also. So we don't need the big transformers and the filters anymore. And the driver for this is like we see that steps almost at a step a decade. With the improvements primarily in efficiency, but certainly this has made UPSs a lot lighter and a lot more compact and improved the efficiency dramatically as we've gotten rid of all the heavy magnetics. In today's world, like the third box from the top, the red circle with states transformerless UPS 3-level IGBT, that's where practically all manufacturers are today. Most UPSs, and true for all ABB UPSs, are around 96.5% efficiency. Give or take a little bit, but it's in that area. The green box at the top is the economy mode I talked about. It's available. Practically all UPSs can do it. Very few customers want to use it because that's, I guess, a popular way. That's not why I bought a UPS. And then the next step on the development component-wise will be silicon carbide. They're already out there. There's one manufacturer that have launched one product based on that, but the components are very expensive still. So we're waiting for the volume of scale of manufacturing to get the price competitive, and then we can get up to a double conversion online efficiency around 98%. In which case, efficiency-wise, it would hardly make any sense to use economy mode. So before going into the module, I'm going to look a little bit about UPS configurations and what we have seen over the decades. So look on the left side of this slide. Just look at that as a one line and just a picture of any UPS, but a one line of that single UPS system that was originally designed well over 50 years ago. And what happened and what have driven development of different configurations and the features and specifications for UPSs is that we learned, that was before my time. I'd been in the business for a while, but not all the way back then. Very, very rapidly, like the good old truth that anything man-made will fail. Which means that now we put a UPS in the line between the utility and the critical load, but that single UPS is also a single point of failure. It does offer filtering, it does offer backup, but if anything happens on anywhere on that single power line between utility and the load, it's still not a good day. So to address that, the UPS industry came up with, we started paralleling UPSs. Actually, the second reason for doing that is that what has been true ever since, we need more power. Like the IT business, data center business seems to have an unlimited appetite for power. So a way of getting to that is by paralleling UPSs, and you parallel two UPSs, and now you double the power capacity. So the first, and the way this was done in the business, paralleling, was using a special version of the UPS and then a system control cabinet to control the operation of the parallel system. So the picture, the single line, the one line, and just the illustration on the right, just showing now we have 3 UPSs in parallel and 1 system control cabinet. And the UPSs are not really true UPSs. They're just rectifiers and inverters, and that's the way it used to be when we started paralleling UPSs. And there's still some control in the UPS, obviously, to control the operation of the rectifier and the inverter. But the system control, like the load sharing, the synchronization, that's all handled by the system control cabinet. The system control cabinet also holds the static bypass switch, which in this case has to be rated for the total system power. So this works now, and I should say, I think most of my drawings, and this is my level of PowerPoint, so forgive me for that. I use 3 UPSs in parallel. For most manufacturers can parallel easily up to 6 UPSs, but to have it somewhat visible on the slide, I limited it to 3. So this of course it serves the purpose. Like 3 inverters, 3 UPSs in parallel now can support 3 times the power. Or if the load can be supported by 2 of the inverters, it offers what we refer to as N+1 redundancy. And so that was the beginning of paralleling. And then the next step in the development was ties back to, and I guess part of this is, and reason for talking about that is also illustrating that sometimes history repeats itself, or you could also say we learn from history. And I'll get down to that later in the presentation. But I guess the business, the industry learned the same lesson again. Like we have the traditional paralleling with a centralized paralleling control with a system control cabinet on the left. And also, again, anything man-made will fail at some point. And if what fails with this configuration is an inverter, it's not so bad. If we have N+1, like we have 1 extra. But if anything fails in the system control cabinet, it's still a bad day. So the UPS next step of the development and the UPS business was actually what we refer to as decentralized paralleling. Of course, part of this became possible with development of better controls instead of analog control, like going to microprocessor controls with a lot more computing power. So getting to a point where now in a decentralized paralleling, we can parallel single UPSs. And again, I'm showing 3, but this could be 4, 5, or 6 in parallel. And it's essentially paralleling single UPSs, and they operate the same way, except that each UPS is now a complete UPS. It has its own static switch, its own control logic, its own display, and so on and so forth. And because of the more powerful control for the microprocessor, each UPS in this lineup can control the operation of the total system. They are connected communication-wise, but it's a much more reliable system, because if anything happens to any of the UPSs, like if UPS 2 is having a really bad day, doesn't matter what it is, UPS 1 or UPS 3 can just take over and control the operation of the remaining part of the system. So in the name of high availability, the decentralized paralleling was invented. Obviously, it also makes it a little easier manufacturing-wise. Now you don't have to make a special UPS that's just a rectifier and inverter, and you do not have to manufacture system control cabinets. So I say this, so centralized paralleling decades ago, decentralized have easily been like 2 or 3 decades back since when that was first developed. And so I believe there's actually still 1 manufacturer out there offering centralized paralleling. Some customers are this was a backbone in large data centers in the US for at least a couple of decades. And some customers are very comfortable with having a big static switch that is rated for the full. Typically, that would be 4 750 kVAs in parallel, and the static switch would be rated at 3000 amp. And for some facility managers, it's like comforting. They had that big thing sitting there that could handle the entire load. The drawback, as I mentioned, of course, is that if that single big static switch had an issue, the system could not go to bypass. So by far the majority of paralleling done today, if not all, like certainly close to 100%, is decentralized paralleling. And then moving into getting a little closer to what will be the rest of the presentation is like, obviously we have modular UPSs. So the UPSs I've been talking about so far is what we refer to as monolithic. Like at 500 kW is a 500 kW. That's what it knows. That's what it's designed to. Everything in the UPS is rated to support 500 kW. So the rectifier, the inverter, and the static switch is designed for that. If you need more power, like we just talked about, we have to parallel another 500, or could be a 750 or 1 megawatt, but 500 just as example. And we can parallel more of them, and we can support more power. And then the newer, which would be the major topic or the majority of the topic today, is the modular UPS, which at least in the ABB world is just a metal cabinet that can hold a number of smaller UPSs in parallel. So that's the picture at the bottom right here. That's a single line of a 500 kVA ABB Modular UPS. I'll get more into detail with this, but before I jump all the way into the modular UPS, I'll talk a little bit more about the monolithic, like the traditional, because the industry have, I guess you can say, we've done a decent job at causing some confusion, because even monolithic UPSs today are actually modular. So I have a couple of slides here, and this is just showing the ABB offering. And so there are three different product families in the ABB monolithic UPS offering. And actually, this is one of the ones that the mid-power TLE is actually a legacy GE UPS that noticed the GE logo on this one this morning. So just for illustration, that mid-power TLE UPS is actually based on a 50 kW power module. It's available from 40 kW to 150 kW, and that we see on the right here, the unit will support 150 kW. The module is just a rectifier and inverter. It's just the power module. There's nothing else. Like everything else is centralized in the frame, the static switch, the control logic, the display, everything else. And it is a power module, but it's bolted in. So the reason for this design, and this is not unique to ABB. Like all manufacturers in the industry today are doing it like this. They're building monolithic UPSs like this. And of course, it's a matter of volume of scale manufacturing wise. Like you build one power module, in this case a 50 kW, and then you build frames that can take a number of that 50 kW. You bolt them in, and then it's not meant to be a modular or scalable product. You close the door, and this is 150 kW UPS, and that's what it knows. That's what it can do. There were never, and that's true for not only ABB, but for all vendors in the industry. It's not meant to be a scalable product. So just for illustration, it's very parallel to the next two slides. I'm just very quick. The high power TLEs are same thing for the ABB UPS high power TLE. This product box is now just based on a 250 kW module. So the one at the bottom here, we can see there are two modules. It's rectifier and inverter, 250 kW, one frame that has space for two of them, and the one in the middle of the slide here with like all the doors closed actually have four of them built in, but they're bolted in, and they just are hard in parallel, offering one, like in the big one, 1 megawatt of power. As I said, not unique to ABB. This is true for any UPS, any modern UPS. If you open the doors, that's what you would see. And just one comment before somebody wanders and asks, for the high power is a 250 kW module. Same as with the mid power, from 40 to 150. In this case, 160 to 1 megawatt. A 160 kW is essentially a 250 kW that has been told now you're 160. Mechanically, it's the same as a 250. In most cases, that's true for most manufacturers. It's just been told it's a derated version, and that's another way, like cheaper way of broadening your kVA product offering. And then the last picture on this, until I will go in on the modular side, is another ABB UPS. In this case, based on a 400 kW power module. And as this is bigger, the module, that 400 kW module, which is still just a rectifier and the inverter, they bolt into the frame. 4 of them bolted into that frame makes it a 1.6 megawatt. Again, nothing unique for ABB. It's I guess you can say all UPSs, all static UPSs in the market today are modular, basic module design. They're not all scalable. The ones we originally knew as modular UPSs are modular scalable. The ones that showed up until now are all monolithic type UPSs. They are what they are. So this is just a quick view of the ABB three-phase 480 volt monolithic offering. The little one up to 50, the medium to 1 meg, and the big one up to 1.6 megawatts. So going into the modular UPS design, and actually what drove this, and like everything else, obviously it's well, newer and better components became available, and creative engineers figured out ways to use them and solve customer problems that way. So from a practical point of view, and I talked about paralleling UPSs before, and so in this case I used 400 kW as an example. It could be anything, but say a customer is building, so with a 400 kW it would not be a hyperscale data center, that would be a small to medium sized data center. Is building a data center, they anticipate that at full build out the load will be 400 kW, and they require an N+1 redundancy. So with a monolithic type UPS, your only option is that you install 2 400 kW UPSs. It's very possible that the load from day one until the customer starts to add the load and build out the data center, the load may only be 50 or say 60 kVA. They still need the 2 400 kW UPSs to support that and achieve the N+1 redundancy. And that's where the modular UPS comes in. Like one frame with space for smaller power modules is also what we refer to as a scalable solution. You can put in the frame that in the same picture as I used before. This is a 500 kW ABB UPS module fully populated like this. It would support 500 kW, but it will also, as there's space for 5 times 100, it'll also support 400 kW with N+1 redundancy. What would make that attractive to the customer, or the example I just gave, is that the customer can start by installing the frame and putting 1 module in there, or 2. 2 modules will give him up to 100 kW N+1 redundancy, and then as they add more load, they can add more power modules up to a maximum of 5, but they get the same redundancy in practically half of the footprint, and they get to. There are a number of buzzwords there, like the pay-as-you-grow, right sizing, or eliminates stranded capacity. The benefits with having a modular solution. Part of this also is that it's not that there were no modular UPSs before, that there were, but this mainly took off around the new millennium. Back when everybody was very worried about that the computers wouldn't figure out how to change that digit number 4 from 1 to 2, and that we were going to crash, all of us. And data centers were built. We were starting to see colo data centers also. And I remember, like some of you may remember also, right after that, there were data centers, especially colo data centers, that were built fully equipped, and with a build it and they will come philosophy, and the customers never came, or they didn't come fast enough. I do remember seeing like still fully created 750 kVA UPSs being offered for sale on I don't remember if it was eBay, but certainly on the web. They had been bought and shipped, delivered, but never installed, and that company went out of business before they got that far. So pay as you grow and right sizing became very true to a lot of people in the business, and it was a good reminder to everybody, and there was from the market, there was a need from something that would scale so that they didn't have to overinvest from day one. That also drove development of modular solutions. So having talked about that, the next two slides is like when, and so this is certainly after I entered the business, when we started developing modular UPSs. The first modular UPSs is what we would refer to as a centralized design. And the one line you see on the left here, again, this is like just with 3 modules. There are modular UPSs today, I believe, with up to 20 power modules that can go into the UPS frame. But the first, I refer to them as generation 1 modular UPSs, were centralized design, where the power modules were just the rectifier and the inverter, and everything else was fixed, installed in the UPS frame. So thinking back, and this is kind of the reason why I went through the history of how we progressed through the development of paralleling monolithic UPSs. This is very similar. In this case, the UPS frame, the cabinet, is taking the role of the system control cabinet, and customers can slide in module, like in this one, showing 3, but like as I mentioned, I know there are products out there with space for up to 20 different modules. So it serves the purpose. Customers can add modules as they need them, and they can have built-in redundancy. Like in same example like before, if 2 of the power modules here can feed the load, there's n+1 redundancy on the power module at least. If one inverter fails, it's not really a bad day, because the customer lost redundancy, but the other 2 inverters can feed the load. Or if it was 19 out of 20, 19 could feed the load even if one of them fails. The issue with this design, and this is why like we learn the same stuff over and over again, is that if anything in that pink box, which here illustrates the UPS frame, if anything there fails, it doesn't help that there's redundancy on the power module side. It's still a bad day. Like the load is still down. So same lesson as was learned with paralleling UPSs with the system control cabinet a couple of decades before. So the fix to that was exactly the same as before, only now in a modular design. So this very similar single line or one line, but this is how modular UPS, like the evolution of modular UPS to what I refer to as generation 2, which is again a decentralized parallel architecture, decentralized design. It's just paralleling complete UPSs in a frame in a modular UPS, instead of needing like having the control logic and the display and the static switch as shared components, fixed mounted in the frame. So the most modern, the latest generation modular UPS, this is the design we see out there. And of course, what it's all about, and this is kind of just for a practical example, it's about eliminating single points of failure. And I'm not 100% sure. We don't see 4-engine planes that much anymore. Most of them are dual engine today. And from looking up, I believe all 4-engine planes could, when they were in the air, they could stay there on only one engine. So they would have, like we would refer to as N+3 redundancy. Takeoff would be a different story. And I do know that all dual engine planes can fly on one engine. So there's N+1 redundancy there. If something happens to one of the wings, it's a different situation though. And so the whole design, like an UPS, customers get a UPS for a reason, and the design evolve and improve is to eliminate or try to eliminate every single point of failure. I don't know if the airline industry will ever get beyond this one, but it may be not that likely that the wings should fall off a plane. But just as a parallel, something to think about if we ever get back up flying again. And then, so from the ABB side, what ABB did, and I should say ABB was building, and actually that may be a little bit of a stretch, because ABB was in the UPS industry many years ago, then exited the industry, and then in 2008 started acquiring different companies in the mission critical industry. One UPS company in 2008, another one 2012. But one of those companies had been building modular UPSs since, like in the US market, I think APC, American Power Conversion, had paved the way for modular UPSs. Very known for that. But the company ABB acquired had actually made modular UPSs before that. They were just never marketed in the US, so most customers or most people in the US didn't know about that. But they were starting out. This is more than 2 decades ago. The ABB company built modular UPSs just like everybody else, like the generation ones, which is basically what everybody else is doing, and including American Power Conversion, APC or Schneider today, are building modular UPSs. But about 12, 14 years ago, ABB came up with this, like I showed the development, it evolved from generation to generation 1 to 2. Just the idea, which was actually not, it was reinventing the wheel. It was like going from a centralized to a decentralized concept. And ABB developed 2 power modules, like slide-in power modules for modular UPS, this is not from 14 years ago. This is the latest generation of that, but based on that concept that the power module is it's not just a rectifier and an inverter, it's a complete UPS. So today in the North American market, we have 2 different lines of product, a 208 and a 100 and a 480 volt. The 208 is based on the 20 kW, the 480 on 100 kW, and the center of the slide here, both of them are complete UPSs. Like everything, like they're both based on latest generation IDBT for the rectifier, the inverter. They got like full microprocessor control logic, static bypass, and built-in backfeed protection, which by the way is a UL requirement. It's all in the box, but the box is a module that slides in, and in that frame can create a modular UPS. So just quick going over the ABB offering, and they're at the 208 volt, and that's based on that same 20 kW module I just showed. There's one frame it'll house up to 6 of them. So it'll support up to 120 kW. That's what it's rated for. But obviously a customer can start with 1 or 2 and then add more as needed. And ultimately, this, because it's a decentralized or distributed configuration, it'll support a true 100 kW N+1, because it's essentially 6 small UPSs operating in parallel. So this is another simpler way of like just showing the single line of what that UPS looks like. 6 small UPSs in parallel in one frame. In the 120, no space for batteries. Batteries will be in an external cabinet, which leads to the next frame based on the same module and actually the same cabinet, but only leaving space for 3 of the 20 kWs, thus the name DPA60. Can support like fully populated up to 60 kW or 40 kW N+1, but it's got space for built-in batteries. Same power model, so exactly the same concept. And if we jump to the 480 volt, like the bigger boxes, based on what we see at the bottom here, that 100 kW power model, which is a full-blown UPS. There are 2 different frames. One will house up to 3 of them. One will house up to 5. And like the other ones, customer can start with 1 or 2, and they can add more as needed. But for modular UPS, it's just like monolithic. If we run out of space, if we get up to 5 and we need more power, we can parallel another cabinet to the next one, or to the existing one, and continue to add 100 kW or for the 208 20 kW power modules. But they're all based on the same design. So this is a little bit more, slightly bigger, but that's one line. That's actually a 500 kW UPS. You close the doors and it operates. It supports 500 kW, but it's actually 5 100 kW 480 volt UPSs in parallel. They all have their own control logic. Every single one of them can control the operation of the entire system, but it operates like a 500 kW UPS. And because of the decentralized design, it offers a true N+1 redundancy up to 400 kW. So this is fully populated. Of course, this could have started out with 1 or 2 modules and then space to add more. So same as I showed just the lineup or the ABB offering for monolithic, this is the ABB offering for modular. The 20 kW module used in the 60 and 120 kVA frame, 208 in and out. The 60 with space for built-in batteries. The rest, the other 3 modules require external batteries, like most bigger UPSs. And then the 100 kW module basis for the 300 kW frame and the 500 kW frame, all of the modular scalable products. So communication-wise, and just pointing, we talk like eliminating single points of failure. I mentioned that the UPS, the little module, the 20 kVA or 100 kW at 480, have their own display. They're complete UPSs, control logic, display, everything. So this slide just to illustrate the slide or the display on the top left corner that's a nice color touchscreen that is on the front of the cabinet. You close the door, now you have that 120 kVA UPS. It'll operate like a 120 operator on that display. Like just take, like essentially, like you would operate 120 kW monolithic UPS or 500 if it's the 500 kW. But each 100 kW, each module in the modular UPS actually have their own display. And the benefit with that is that if the one on the front of the UPS should go blank for whatever reason, and then we are back to anything man-made will fail, it's just a question of time. I can open the door and I can go to any display on any power model in the system, and I can still operate the entire system. So that little one, the power model display, of course, it doesn't look as fancy. It's not a color touchscreen display. It doesn't have the same level of system data, but it can operate at a system level. So with the design, we added redundancy on the operation side as well. Just like they're actually a small HMI or display on every power module, on every little UPS, makes it a complete UPS. Other than that, communication wise, and by the way, this is true for all ABB UPSs, not only the modular ones. There's relay, like the good old fashioned. This is what UPSs did when I started in this business. There were typically standard two relays. One was a common fault. Anything would trigger that relay, and then the other one was battery operation. Often wired to a big bell or a horn outside the UPS room. But so the UPSs come standard with a communication board like that. Over the years, stuff have been added, like we can have signals from a generator if we want to limit battery charging while on generator and stuff. What you would expect from any modern UPS today. Actually, on that note, if you compare data, like all I mentioned earlier, I believe in the presentation, all UPSs are now, like the majority of UPSs in the market are the IDBT rectifier and inverter, double conversion, power factor corrected input, unity rated power factor. So 500 is actually a 500 kVA will support 500 kW. That's true across the board. And the efficiency, even if the modular UPSs are based on smaller power modules, but the 500 is still around the same efficiency as a monolithic, pretty much like any UPS or similar sized UPS in the market. And then again, this just a slide. This is the connectivity options for the modular UPS, but this is true across the board. Like most data centers use Modbus, smaller ones tend to prefer SNMP. But we support BACnet. Profibus actually was fairly new to me, but is very well known in Europe. So maybe I should have known. But it's primarily used in industrial applications. It's a protocol that's primarily used in industrial applications in Europe. But there are customers using it in the US also. So the short comment on that is, do you support that? Yes. So summing up on this on the modular, and actually that is the ABB Modular UPS, is that they are based on the on generation 2 modular design. And as I mentioned, the engineers with ABB who developed this, they just, and that may sound wrong, it's not that they invented anything new. Like this had already been done once before with monolithic UPSs or paralleling, going from a centralized with the system control cabinet to a decentralized where we could parallel single UPSs. That's the same thing. Like the ABB took that step from the modular. I think it's the only manufacturer, like most manufacturers, most vendors offer modular and monolithic type UPSs. But I believe the ABB one is the only one currently with a decentralized, like with a full N+1 or technically also N+2, whatever is required, redundancy in one frame. The UPS cabinet, and lack of a better word, is just a dumb metal cabinet. There are plugs where you plug in the power module, and they're connected with bus bar and cable, and there are bus their terminal to land the input and output and battery cable. But there are no active components in the frame. That's all figured out between in this case, 5 power modules, but the illustration shows 3. And then, of course, the benefit with the ABB modular UPSs is the same as any other modular UPS. It's the flexibility. Is that you can easily scale. You can add modules, and you can add modules as needed. You can slide in additional modules if a module should have a bad day, and like I said, anything man-made will fail. The UPS will tell which one it is. The control will tell which one it is, and repair time or mean time to repair is we're talking minutes instead of hours with a monolithic type design. So the main benefit with actually, I guess there are two. It's like one is the ABB Modular UPSs offer the integrated redundancy due to the decentralized design. The other is that what not all vendors or manufacturers of modular UPS offer is what we refer to as online swap, which is like essentially hot swap. You can swap a module on a running UPS. You can add a module, excuse me, on the fly on a running UPS. Doesn't mean that customers are going to do that. Some customers may be more comfortable bypassing the UPS, like going to bypass and then adding the module or swapping a module and then going back on the UPS. That can be done in a couple of minutes, but it can actually be done. The UPS is designed so that it can be done on the fly. Those are some the flexibility and the ease of adding capacity of repairing a faulty system is the benefits with a modular design. Other than that, it's the same buzzwords that we've been hearing for a couple of decades close. It's like the pay as you grow, eliminate stranded capacity and right sizing. Same as we'll hear with all modular scalable products. And tying back, as I mentioned, even all monolithic UPSs are actually modular in design, even when they don't operate like that electrically, or even if today you were to build a monolithic UPS with a 1 megawatt rated inverter, it would still have parallel IGBTs in there. So whether it's smaller modules with each with their own set of IGBTs that operate in parallel, or a bigger one, electrically doesn't make a big difference. So last slide, the modular ABB, like any other UPS, all ABB UPSs are parallel, and this train, like locomotive, whatever, the big black line of UPSs here, just to illustrate, like we talk about two-dimensional scalability. Like one customer can start with one frame and one power model, and then you scale vertical until you run out of space, and then you can add another module next to that or another module next to that. That can actually, and I've seen that. I've not seen it done in the field. I've seen it done in the test bay. They were starting out with 3, and as part of the factory acceptance test, they wanted to see the hot swap of the power models. That was done on 2 units in parallel, supporting a megawatt, or like close by 900 kW load, and then swapping modules without shutting down. And then the customer wanted to see how they could add a 3rd module, again without shutting down. And the test technician, it was a test base, so the cable was just pluggable into the feeds and to the load and so on. But just wheeled in the 3rd UPS, plugged it in, and so that and closed the breaker so it was parallel with the first 2, and increased the load from 1 megawatt to 1.5. Never went to bypass, never shut down, never did anything. So that doesn't mean any customer, and I doubt any customer would ever do that in the field, but the unit is designed to do that. So other than that, I guess the key word is the integrated redundancy and the flexibility. We have customers that have started out with the black train, you see, like 6 frames in parallel, with the modules installed that they needed from day one, and then they're just plugging in modules as they need them. And we also have customers that have gone the other way, like they start with 1, and then if they run out of power, they need more, they can parallel extra cabinets to the first one. It adds a level of flexibility we do not have with a monolithic UPS, a granularity. The other thing, and what actually a couple of colos have brought up to me as a benefit, is that with a modular design like this, if you deploy your campus with modular UPSs as a colo, of course you want to rent your space, you want people or customers in there all the time, but sometimes they leave and go somewhere else, and sometimes you don't need the full power everywhere on your campus all the time. This adds the flexibility that you can move power models around from UPS to UPS. So you can move capacity from one part of your data center to another. If you have excess capacity or more power models than needed in one UPS or one group of UPSs, you can move some to another UPS if there's space. So that was my last slide. So if any questions, I should be able to see please feel free to write. I'll go on to the last slide, which with my contact information. Please feel free to reach out with any questions, whatever's easier for you, like whether it's phone or text or email. If you have any questions, then please feel free to reach out anytime. But it's about 5 minutes left to go. If anybody has questions, and then please type them in. So I don't see any yet. I don't know if that's because I'm working out of my home instead of and logged in to this instead of Michael being able to see being in the office, being able to see the questions there. So it should work, but like I said, please, if you have questions, please feel free. If not, like I said, you're more than welcome to reach out anytime, anyway, whatever's easier for you. And if no questions, I thank you very much for your time today, for spending your lunch hour with us here, like going through the ins and outs of, well, a little bit of UPS history, and most part of it on the modular UPS side. So it's quiet, actually. It's quiet on the question. The little white space for questions here too. I know, as I understood from Michael in the introduction, is your microphones have been muted, so this system apparently does that automatically. So not much. I probably can't do anything about that. But I'll leave it open for a little while. We are coming up on 1 o'clock. So it looks like there at least until now, there are no. It is one. I don't see any questions. I don't know if that's a system issue or it's probably not, because I covered everything. I didn't, or nobody wondered about anything along the way. So I don't know if it's a system issue or it's just because there are no questions. So like I said, you're more than welcome to reach out. Please do. Even just comments, like doesn't have to be a question. Any comment, whatever. That's what we're here for. So as I don't see anything, and back to the microphone comment, also don't hear anything, I will close it out for now. And then again, thank you so much for your time. Have a wonderful Wednesday afternoon, and which means that right now we made it just over halfway this week. The weekend is getting closer. You know what they say, like the first 5 days after the weekend are the hardest. So now we only have 2.5 days left. Have a wonderful day. Have a wonderful rest of the week, and I will close it out for now. Thank you.